the gene for dimples is dominant. In a certain population of 3,000 people, 800 people have a dimple. How many people would you expect to have each of the three possible genotypes? So we're asking for what we would expect. We're not really being told that this population is in fact in Hardy-Weinberg equilibrium. So we're going to come up with our expectations. So if dimples is dominant, and we consider the people that we would expect to have dimples, this is going to be represented by the genotypes big A, and then also the heterozygous. And we're told in the question that there's 800 people out of 3,000 that actually have that dimple phenotype. As far as no dimples, this would be represented just by the little a genotype. And so if 800 of the 3,000 have dimples, then we can assume that 2,200 of the 3,000 do not have dimples. So if we just turn those into frequencies, if we look at the percentage that do not have dimples, it's 2,200 divided by 3,000. And so this right here is going to be equal to 0.733. Okay, so remember that little a, that frequency is Q squared, and we just figured out that the frequency of no dimples is 0.733. Again, we're kind of making the assumption here, calculating these allele frequencies. We're making the assumption that the population is in Hardy-Weinberg equilibrium, but we don't necessarily know that. So if we take the square root of both sides so that we can solve for Q, Q is equal to 0.773, its square root, which is 0.86. And so that's Q, and if P plus Q equal 1, then P is going to be equal to 0.14, okay? Because again, these have to add up to 1. So if we wanted to look at how many people we would expect to have a dimple, it may not come out to be 800. So if we first calculate the frequency of big A that we would expect, this would be P squared. So we would take 0.14 and we would square it. And so if we took 0.14 and we looked at that squared, this is equal to 0.02. If we were to look at that and calculate how many people would have big A, we would take 0.02 times 3,000. Okay, so when we do that, that should be 60 people right there. If we look at the heterozygous ones, heterozygous is 2PQ. Okay, so this is going to be 2 times P, which is 0.14, times Q, which is 0.86. So if we multiply that, we get 0.24. And so if we look at 0.24 times 3,000 to get the number of individuals, we get 720 individuals. So when you look at those together, we add them up. You have the 720 plus another 60. We're getting 780. It's not exactly 800 that we're told up here that have dimples, but it's pretty close. So I'm just going to write these up here in the number of people that we've identified. So 60 of them should be like that. Heterozygous should be 720 of them. And if we wanted to know the little a, we've really already figured out that there's 2,200 of them. But if we look at what we would predict, we would have little a, and that is Q squared. So we would look at 0.86 squared. And so 0.86 squared is equal to 0.74, okay, and that's pretty close to what we had up here. And so if you take that and you multiply it by 3,000, you get 2220. Okay. So numbers that are very close to Hardy-Weinberg equilibrium as far as what we have in our population.